Welcome to The Explainer. So, today I want you to step into the shoes of an incredibly ambitious space entrepreneur. We aren't just talking about launching a few satellites or taking a quick joyride into orbit here. No, we're talking about conquering the entire solar system. See, every planet out there is hiding buried treasure worth hundreds of trillions of dollars, just lost to the eons of time. But to get it, and to build an absolute armada of space miners, you're going to need a flawless step-by-step strategy. So grab a shovel, or actually an automated mining drone, because we're mapping out exactly how you can build a solar system-spanning mining empire. Okay, let's dive into this step-by-step roadmap for outward expansion. We'll start with the lunar staging ground, move on to tackling the inner planets, hit the asteroid belt jackpot, scale things up by siphoning the gas giants, and finally, we'll wrap it all up by building the Dyson sphere. All right, Section 1, the lunar staging ground, starting close to home. Look, before you can get filthy, stinking rich, you've got to start small. Building a fleet of spaceborne ships requires some really fundamental materials, and you need a base of operations close to home. The Moon and Mars are absolutely critical for gathering the basics, things like oxygen, silica, aluminum, iron, and titanium. Now, what makes the Moon the perfect starting line is regolith. You can literally leave your blasting caps back on Earth because the Moon has been completely pulverized by meteorites for billions of years. The surface is just covered in this dusty regolith, sometimes as deep as a house. This is pure mining goodness. You don't need heavy drills. You basically just hoover it up, dump it into a smelter, and start cooking out the metals and glass you need to manufacture your very first ships. Now Mars, it operates on a very similar principle. It's covered in this red iron oxide dust, what we'll affectionately call your red gold. Since gravity there is just 1/3 of Earth's, gathering this surface dust is incredibly efficient. It's the absolute perfect, easy surface picking to start constructing your first massive ship exoskeletons. You scoop it up, load it into a rover, and you are literally smelling the progress. Well, actually, scratch that. You'd be smelling toxic vapors, but you get the idea. But here's the ultimate roadblock you're going to face early on: a total lack of easily accessible water. And that's a massive hurdle in space mining. See, on Earth, when you drill into rock, you need a lubricant, specifically drill mud or water, just to keep the drill bit cool and flush out all the cuttings. If you had a fracture on Earth, you might lose millions of liters of water in a single day. On Mars or the Moon, yeah, you can't afford to lose a single drop. Plus, water is absolutely critical for hydrogen rocket fuel. Because of this, traditional drilling is totally out. You're basically forced back to old-school cable tool smashing. Think of it as a highly evolved pickaxe, just violently smashing the rock to get what you need. Which leads us to a massive problem. You've got the building blocks for your ship, exoskeletons. But how do you actually power this growing fleet? Fuel is in seriously short supply. To upgrade your tech, we're going to have to look toward the most dangerous, downright hostile environments in the entire solar system. Which brings us to Section 2, tackling the inner planets, embracing the inferno. We're heading toward Mercury and Venus. Now, this is a high-risk, high-reward logistical nightmare, but the payoff is exactly what your growing fleet desperately needs. First up is Mercury. Just look at these crazy temperature swings. It's essentially a cooked rock, facing 430 degrees Celsius during the day and then plunging to -80 degrees at night. Throw in some massive magnetic tornadoes, sending solar wind plasma just streaking across the surface. So yeah, finding human staff for this gig is going to be totally impossible. But the thing is, Mercury is completely covered in graphite and phosphorite, which is loaded with magnesium. To get it, you deploy these automated, solar-powered laser cutters right in the temperate terminator zone. That's the line between day and night, using robot-powered solar smelters to literally carve chunks out of the planet and fire pure aluminum, oxygen, and magnesium right back to your bases. Now, what's really interesting about this next target is the sheer density of Venus. The surface is potentially 20% iron oxide, and the core, an unbelievable 80% metallic iron. It's essentially Earth with no people, an absolute Goliath of a resource just waiting to be pillaged. But let's ground ourselves with a quick reality check here. You might be tempted to build giant Zeppelins and launch probes, but they'd meet the exact same fate as the Russian probes back in the 1970s. They'd just melt. Operating in 467 degrees Celsius heat within a crushing, lead-melting sulfuric acid bath is a total disaster for any machinery. So after losing a few dozen ridiculously expensive robots, a smart entrepreneur defers Venus for later. We need a much more lucrative, slightly less hellish target first. Let's move on to Section 3, the asteroid belt jackpot, astronomical wealth. This stretch of space right between Mars and Jupiter is basically a floating gold mine of protoplanet cores. Take just one single asteroid, Psyche. It's about 280 kilometers across and totally packed with nickel, iron, and platinum group metals. The estimated value? $10 quintillion. Compare that to the entire Earth's global annual economy, which sits at a mere $125 trillion. Just let that huge number sink in for a second. $10 quintillion. That single piece of rock is worth 80,000 times our entire planetary economy. And the crazy part? There are potentially 2 million asteroids just as big or even bigger floating right out there. Of course, getting it back safely is the real trick. I mean, look at NASA's recent OSIRIS-REx mission. They spent hundreds of millions of dollars and 7 whole years just to bring back 122 grams of asteroid. Like the original source material jokes, that's like waiting 7 years for a quarter-pounder with no cheese. You definitely don't have time for that. Your highly automated drones will just punch holes into these asteroids, pack them with explosives, and blast chunks of rock and metal directly back to your orbital smelters circling Mars. But here's the bottleneck we hit. You now have endless metal from the belt, you're building ships incredibly fast, but you are totally out of rocket fuel, and you still have no water to efficiently drill. You've got to stretch your supply lines out to Jupiter and Saturn. Section 4. Siphoning the gas giants. Solving the fuel crisis. Now, you obviously can't really mine a gas giant's core, but you can absolutely skim gas from the upper atmosphere. And even better, these surrounding moons are your ultimate space gas stations and water taps. Jupiter's Europa and Ganymede are just massive water mines. Saturn's Enceladus literally sprays water directly out of surface geysers into space, and Titan, it's covered in sprawling seas of methane and ethane. You literally just drop a hose from space, siphon up the liquid, and suddenly you've got rocket fuel for trillions of lifetimes. You've created a system where no ship in your fleet is ever running on empty. Once you have water and fuel flowing freely, you can push all the way to the outer limits of Uranus and Neptune. Out here, you transition from a mere miner to a full-blown space farmer. The moons Umbriel and Triton are packed with frozen carbon dioxide and nitrogen, which is absolutely perfect for growing plants and sustaining human life. You can start building O'Neill cylinders, these gigantic megastructures designed to perfectly mimic Earth. And hey, just in case you need a little nest egg, you can plunge into Neptune, where immense atmospheric pressure creates iceberg-sized diamonds, literally raining down inside the planet. At this point, you have officially reached God-tier wealth. Which leads us perfectly into Section 5, building the Dyson sphere, the ultimate megastructure.
So, the crucial point is, with the asteroid belt netting you $10 sextillion, money is now completely meaningless. There simply isn't enough money in the entire solar system to buy your resources from you. So, you pivot from wealth accumulation to a massive philanthropic mega project to cement your legacy. To elevate humanity into a Kardashev Type 2 civilization, which is a society capable of harnessing the total energy output of its star, you execute these mind-bending logistical steps. First, you finally go back and strip mine that hellscape, the entire planet of Venus. Second, you convert all of that immense 80% metallic iron core into usable sheet metal. Third, you completely enclose the sun with a wall 30 meters thick. And finally, you capture 100% of the sun's radiation. You gift this near-infinite energy to Earth, Mars, and all your expanding space colonies, leaving the next generation the power to explore far, far beyond the Kuiper Belt.
You've completely outpaced every billionaire in human history. You've conquered the solar system, captured the sun, and totally rewritten the destiny of the human race. But stopping now would be a real shame, wouldn't it? As you look out into that vast, dark expanse of the Milky Way, it leaves you with one final undeniable question. What are you going to build when humanity expands to a Type 3 civilization? Keep that ambition alive. And thanks for joining me on this explainer.